This video is going to discuss a concept known as the limiting reagent, and then I'm going to keep going into a related concept known as percent yield. The word reagent, you'll also hear me use the word reactant. They're the same thing, so they can be used interchangeably. Right? So for a limiting reagent, we're talking about in a chemical reaction, one of the reactants has to run out first. That is going to be your limiting reagent. So the limiting reagent, is the chemical species that runs out first in a reaction. Because if one of your reactants gets entirely used up and runs out, well then without one of the reactants that are necessary for the chemical reaction to take place, that limits the ability of the reaction to proceed, and the reaction is done at that point. So, so again, another point is that the limiting reagent will always be used up in its entirety. So to kind of explain this, let's say we're trying to make a sandwich, and you're going to make just a basic sandwich. It has 2 slices of bread and a slice of cheese. Right? So, represent bread. That's my very clearly artistic drawing of a slice of bread. And here's a slice of cheese. So you need 2 slices of bread and 1 slice of cheese for each sandwich. Right? Well, now let's say we have 4 slices of bread and 2 slices of cheese. Right? So that's enough for 2 sandwiches. So if we were to write this as a chemical equation, we would say 4 bread plus 2 cheese yields 2, and I'm just going to write this below, sandwiches. Right? So what this means, remember, look, these coefficients here, this means that in order to make 2 sandwiches, we need 4 slices of bread and 2 slices of cheese. Right? If we don't have both of those amounts, we cannot make 2 full sandwiches. So now let's say we have only 3 slices of bread. Right? Well, we clearly still have more bread than cheese. Right? We have 3 slices of bread and only 2 slices of cheese. Now, we can take 2 slices of bread and 1 slice of cheese and make our first sandwich. But then we go to make the second sandwich, and we can't do it. Why can't we do it? It's not because we don't have enough cheese. We only need 1 slice of cheese, and we have that. So we have enough cheese for a second sandwich. What we don't have enough of is bread. So the bread is what is limiting us from being able to produce that second sandwich. So even though there's still more slices of bread than cheese, the bread is the limiting reagent because that's the one that doesn't have enough and would run out first, thus limiting our ability to make a sandwich or carry out this reaction. So now let's talk about this in the context of an actual chemical reaction. Okay. So remember, for limiting reagents, the only chemical species that could actually potentially be a limiting reagent are going to be your reactants, which are on the left-hand side of the arrow. So here we're looking at glucose, C6H12O6, and oxygen. You can see their coefficients here, 1 and 6, right? So again, what that means is that at the same rate that 1 molecule of glucose reacts, you have 6 molecules of oxygen reacting. Right? So it takes 6 times as many moles of oxygen, because remember, these represent the molar ratios, right? So it takes 6 times as many moles of oxygen to react as it does moles of glucose. So if we start with 6 moles of glucose and 6 moles of oxygen, which one would be our limiting reagent? Well, again, we just said that at the rate that 6 moles of oxygen get used up, you only use 1 mole of glucose. So those 6 moles of oxygen would get used up, and you'd still have 5 moles of glucose left. Right? But at that point, the reaction can no longer proceed because one of your reactants is done. So in that case, oxygen is your limiting reagent. Let's say we have twice as much oxygen now. So we have 6 moles of glucose and 12 moles of oxygen. We have quite a bit more oxygen now, but we've already said that oxygen gets used up not twice as fast, but 6 times as fast as glucose. So unless there's at least 6 times as many moles of oxygen, that's still going to get used up first, because we see here if we just double 6, we get to 12, right? So at the rate that 12 moles of oxygen gets used up, we would only use 2 moles of glucose. So oxygen is still your limiting reagent. Let's say we have now 20 moles of glucose and 100 moles of oxygen. We have way more oxygen now, but we still only have 5 times as many moles of oxygen while it's still getting used up 6 times as quickly. So that 100 moles of oxygen is still going to get used up before the 20 moles of glucose. So that would be your limiting reagent. Let's do one more ratio. Let's say we have 4 moles of glucose and 32 moles of oxygen. Alright, now we have 8 times, so 32 is 8 times 4. Alright, so we have 8 times as many moles of oxygen as glucose, and that is more than 6 now, right? So at the rate that, so if you multiply the coefficient of 1 here by 4 to get to 4 moles, multiply 6 by 4 to 24. So at the rate that 4 moles of glucose gets used up, we would use 24 moles of oxygen. So now finally, we have to make that drastic of a difference in order to get a situation where glucose would run out first and thus be our limiting reagent.